Hello everyone, hope you're doing well. Today we're going to be building a simple countdown timer that counts from 9 to 0. I know it's pretty simple, but I'm super excited to build this thing. You actually get to learn a lot about electronics and the basics of electronics in this project, so I'm really excited to show it to you guys. I actually used something what's called a 7-segment display to display these digits, and it displays digits from 9 to 0 by essentially lighting up a particular LED. So it's made up of 7 different LEDs, which I'll get onto later. And I configured the wires, and as you can see, this is the code to loop through the numbers 9 through 0 on the display. And as you can see, I looped it inside the for loop, and this is what it looks like, and I can't wait to show it to you guys. Let's get started. So this is the diagram of a 7-segment display. So it's made up of 7 different LEDs, or segments, that's why it's called a 7-segment display, and an optional decimal point display, which you can use if you want to represent a rational number. So that's how it looks like, and you can represent different numbers like 5, 3, or 1 with this display by lighting up the particular LEDs. So this is the diagram of the 7-segment display model that I used. It's called the 5161AS model. More info is on the datasheet, link is below. But each segment is an LED, right? So an LED has 2 sides. It has a cathode side and an anode side. So the cathode side, which is the negative terminal, is connected to ground, right? And the anode side, which is the positive terminal, is connected to a voltage source. But in order to slow down the current through the LED, and in order to maintain the current, we need to have a current limiting resistor. So this resistor is used to essentially reduce the current that's passed through the LED so that the LED doesn't burn out, because if you have too much current, the LED is just going to take in too much current and it's going to burn out super fast. So we have a current limiting resistor, and that anode is connected to the pin, or is connected to our voltage source. So that's how an LED works, and that's how an LED is used to light up. This is a circuit that is used to light up an LED. And so we connect the resistor to either the anode side or the cathode side, doesn't matter. So the first step is to gather the materials. So we need a 7-segment display, an Arduino board, a current limiting resistor, the 1K ohm, I'm using a 1K ohm, and some jumper wires. Next, we're going to build the circuit. So the display has 10 different pins, the top 5 and bottom 5 pins, and so each pin is associated with a particular LED labeled from A through F. And so the middle 2 pins on both the sides is the common cathode, which is connected to the ground, and the rest of the other pins are connected to the anodes, or the digital pins, and that's how our whole circuit is going to look like. And our cathodes are also connected to the resistor, so the resistor can be connected to the cathode or anode side. So I'm going to connect the common cathodes to our resistor, and I'm going to connect our anodes to the digital pins labeled from 2 to 7, I think, or sorry, 2 to 8. And those 7 digital pins are going to be represented by the 7 LEDs in our circuit. So this is our breadboard, and so I'm going to be building this circuit now. So first off, I'm going to be taking the 7-segment display and placing it on our breadboard. You can place it anywhere, but these are the pins I chose to place this on. It's very ideal if you place it like this, but yeah, I decided to do it like that. I placed the resistor as well, the current limiting resistor, to the side, and then I connected the wires. I'm connecting the wires to the different pins of our 7-segment display. So the top 5 wires are connected on the top 5 pins of the display, and then I'm also connecting the bottom 5 wires to the bottom pins of our display. Now we're going to connect it to the Arduino board. So I'm going to connect that wire from the resistor to ground, because that's how it's supposed to be from our circuit diagram, right? So I'm going to do that first. And then we're going to be connecting the other wires from the pins of the display, except for the common cathodes, to the pins. So I'm going to be using digital pins 2 to 8 for this one. So I'm going to keep on continuing to connect those wires to these pins, except for the common cathode ones, and those are the middle 2 ones, remember, from our circuit diagram. So yeah, keep that in mind. So this is how our finished product looks like. I connected the the cathode wires to ground, and the digital pins, or the pins, the rest of the pins of the display to the digital pins, and that is how it looks like. Looks great, right? And the common cathodes are connected to the resistor, like the top end of the resistor, so the resistor is connected to the cathode end. So yeah. Now we're going to be testing. So this is the code. So the code link is below, by the way, but I'm essentially looping through this. So I'm creating a for loop and I'm looping through all the numbers. I'm setting the number to the I in the for loop, and I'm delaying it by 1,000 milliseconds, and then I'm refreshing the display again. And so that's how it looks like on our board, and it's counting down from 9 to 0. So it's pretty simple, but you can always integrate more than one 7-segment display. So thank you so much for watching, and I'll see you soon.